Assalamualaikum semua. Semua sihat Boleh dengar tak my voice? Boleh dengar suara tak? Clear tak?
Betul.
Okay.
Betul.
Okay, terima kasih. So today we continue our lecture. So hari ni saya cuba I try to finish our chapter 1 So kita lihat kita boleh finish ke tak. Sepatutnya now is week 4. Okay, so we are still on chapter 1. Okay, still on chapter 1. Last week we have covered up to motion of projectile yang ni lah. Okay, so this is your teaching plan. Okay, you can refer back to you learn. We have teaching plan. So this one we have covered, right? So now and today we will try to cover this subsection lah, right? Normal and tangent components, cylindrical component, absolute dependent motion and relative motions. Okay, so you can enter the password for attendance today, dynamics 435. Okay, so today I will go a bit faster. Okay, kalau if you feel like cannot catch up, you can refer back to our recorded lecture, right? So normal and tangential components, right? Like I said last week yang tak habis tu, for curved linear motion we have rectangle components which is SY, and also we have a normal and tangential component, right? So when a particle move along a curved path, okay, along a curved path, sometimes it's convenient to describe motion using other than Cartesian. Okay, Cartesian, this is referred to XY lah. Okay, XY. Okay, sometimes we can use normal and tangential coordinates. Okay, this is normal and then this is tangential coordinates. The t-axis is tangent to the path, okay, and n-axis is perpendicular to the path. Okay, let's say I have this motion. Okay, I have this motion. Right, I have this motion. Okay, at these locations, let's say at this location, let's say it move this direction, right? So at this direction, at this location, you have a tangential component T, okay, and you have normal component. This is we call normal, right? So tangent to tangent lah, tangent kepada curve, tangent to curve, right? Normal must be 90 degree to the curve, right? So this must be 90 degree, right? The t-axis is tangent to the path at the instant considered. Okay, at the instant considered. Kalau kat sini, if I have here, so the tangential must be this direction lah, t, and then this is n. Pada ketika itu, okay, at the time considered. Okay, kalau dekat sini lain. Okay, if you have below, dia lain lah, right? Dia berbeza dengan XY. If you have XY coordinate or Cartesian coordinate, okay, like this one, at this location, X is maintain these directions, okay, X, and then this is Y. Okay, if you have these locations, it's still same. You have X, and then you have Y. Okay, sama saja. Okay, tak kisah kedudukan dia dekat mana. But for normal and tangent component, it depend on the locations, right? And then which one is positive and which one is negative? Okay, for the XY, normally to the right is positive, and then to the up is positive, right? Tapi untuk tangent and normal components, the same direction with one is positive, and then go inwards to the curve is positive. This one is positive. This one is positive, and this one is positive. Right? The n-axis is perpendicular to the t-axis with the position direction towards the center of curvature of the curve. Right? So the direction is toward the center of curvature of the curve. Right? The radius of curvature rho is defined as the perpendicular distance from the curve to the center of curvature of that point. So okay, so this curve you have radius. Okay, for each curve you have radius. Let's say the radius is here. Okay, jari, jari. So this radius we call as a rho lah. Rho. Okay. Radius tu dia tak constant. Okay, maybe at these locations, okay, radius dia kat sini. Okay, maybe dekat, okay, rho. So each location of the particle they have their own radius. Okay, so radius of curvature rho is defined as the perpendicular distance from curve to the center of curvature of that point. Right? Okay, so itu I explain regarding the coordinate system. Right? So now we go into velocity and acceleration in normal and tangent coordinate system. So the velocity vector is always tangent to the path of motions. Okay. Okay. If you have these motions, okay, the velocity vector is always tangent to the path of motion. So velocity is tangent to the path v, right, at these locations. If you have here, so v is tangent to path. This is your v, right? V. So as I said in last lecture, velocity is only on tangent directions. Okay, no velocity in, no v in normal direction. Okay. So here is your t, and here is your n axis. Okay, here is your tangent, and here your velocity is always one direction, same direction with tangent, right? So that is velocity. Okay, now we go into acceleration. What about accelerations? Let's say you have this motion, right? So for acceleration, you have both tangent and normal. So if you I have these locations, so this is tangent axis, and then this is normal axis. Okay. At this location, you have, and then you have normal. Okay, so the acceleration you have both. Okay, you have both. You have A, we call it as A tangent. Hilang Okay, you have A tangent, and then you also have A normal. Okay, A normal, right? Kalau kat sini you have A tangent and you have A normal. Okay, so what is A tangent? A tangent is defined as these equations. Okay, dv over dt, right? dv dt. And then what is A normal? A normal is defined as v squared over rho. Okay, over rho. Rho is radius of curvature. Okay, rho is radius of curvature. Yeah. So the tangential components is tangent to the curve, and the direction is increasing or decreasing velocity. The normal is always directed towards the center of curvature of the curve, and this is explained. And then the magnitude of acceleration is, so you have AT and A normal. Okay, so you should have A tangent squared plus A normal squared and square root to get the magnitude of the accelerations. Okay, so kalau kita ada A tangent ini, okay, and then we have A normal here, so the magnitude is somewhere here. Okay, A, right? A magnitude. Okay. Okay, jangan confuse dengan okay, sama je. Saya bagi. Okay, you have this movement. Okay, again this movement at the top of the curve ni. Okay, let's say here. So this is tangent, and then this is okay. Sebenarnya coordinate system ini sama juga dengan, you boleh bahagikan dengan XY juga. Okay, ini sama dengan if you have X and also you have Y. Okay, the same thing. Alright, the same thing. Okay, so A tangent dalam kes ni, A tangent is equals to A X. Okay, and AY is equals to minus A N lah, because it's indifferent. Right? So you have normal and you have tangent. Right? Okay, special case of motions. If the particle move along a straight line, okay, kalau partikel tu gerak secara garis lurus, let's say here, okay, this is particle. Okay, what is a normal? So sebenarnya ni ada juga. Okay, this is they have the tangent, and then you have the normal, right? Cumanya A normal berapa? So A normal V squared per rho kan? Kita tengok dekat equation yang ini. Mana tadi? Ini, okay? V squared over rho. Alright. So rho, kalau rho lah infinity, kalau straight line, so your rho is infinity lah. Radius of curvature is infinity. You tak ada radius of curvature kalau di straight line. Kalau lengkung, you have radius of curvature. Kalau straight line, you don't have. Bukan tak ada, semua infinity. So V squared over infinity is equals to 0. Okay, so if you have a straight line, so AN is equals to 0. So AT adalah A tangent, you have dV over dt, right? If the particle move along curve at constant speed, okay, so constant speed ni refer to the dV over dt lah, okay, dV over dt is equals to 0, okay. Sebab apa? dV over dt kan V2 minus V1 over T plus T. So kalau constant speed, V2 is equals to V1. So this become 0, right? So you left with AN V squared over rho. Okay. So special case number 3. The tangential component of acceleration is constant. Okay. So you have A tangent constant. Okay. So you can use these 3 kinematic equations. Okay. Kalau AT adalah constant. Okay. Number 4, if the path is expressed as y is equals to fx, the radius of curvature rho at any point on the path is determined from the equations. Okay, contohnya I have this movement. Okay, this movement. Then let's say this is y, and then this is x. Partikel tu bergerak ikut path ni. Okay. So what is katakan path ni jadi equation. They have their own equation. Let's say x squared. Okay, x squared. So what is rho? So rho you can using this equation lah. Okay, rho 1 plus dy dx squared to the power of 3 over 2 over dy dx squared lah ini. Okay, 2 kali 2 times you differentiate the y. Okay, apa rho kat sini lain, okay? Rho kat sini lain. Rho ni you gunakan equation. Okay, untuk mencari if you want to find what is AN kan V squared over rho, AT is dV over dt. Okay, so you want to find this rho, you must use these equations. Alright. Okay, boleh? Okay, we look at the example lah. So we have a boat travels around a circular path. Rho is 40 meter at a speed that increase with time. V is equals to 0.0625 t squared. Find the magnitude of velocity and accelerations at the instant t is equals to 10 seconds. Okay. So you have one boat gerak secara bulatan lah, circular. Okay, bulatan. So they have rho is equals to 40 meter. Right. So find the magnitude of velocity and accelerations at t is equals to 10 seconds. Right. So what is velocity? So velocity you have only one. Okay. Velocity you only have one, iaitu tangent velocity. No normal velocity. So you have V 0.0625 t squared. So ditanya apakah what is velocity at t 10 second, masukkan je lah. 625 10 square. So you get the answer 6.25 meter per second. Okay, so that is your velocity. Okay, and then what is the acceleration? Okay, let's say at this is when t is equals to 0, and then dia bergerak ke sini. Okay, let's say this is when t is equals to 10 second. Contoh, okay, example, dia bergerak kat situ. So what is the accelerations at this point? Okay, so we know that you have a tangent and we have a normal. Okay, so a tangent is dv over dt. Okay, differentiate je lah. You have 2 0.0625 t. Okay, so substitutekan t tu, you dapat 2 0.0625 10. Okay, so you akan dapat 1.25, okay, 1.25 meter per second square. Okay, and then what is A normal? A normal is equals to V squared over rho. Okay. V squared over rho. So masukkan saja 6.25 squared over rho 40. Okay, 6.25 squared over 40, you dapat 0.98 0.98 meter per second square. Okay, boleh? So what is the magnitude? The magnitude tu yang inilah. Okay, you have AT, you have AN, so magnitude tu yang ini. So this is your magnitude. Okay, let's say this is A lah. Okay, so A is equals to A tangent squared plus AN squared. Satu point 1.59 meter per second. Okay, boleh? Boleh tak? Boleh?
Boleh doktor, boleh doktor.
Okay. Okay, kalau boleh buat ni. Okay, dalam masa 5 minit je. Nampak tak gambar ni? Okay. Nanti saya akan bagi slide ni dekat Ulen ataupun dekat subgroup lah saya bagi. Sama je dengan nota yang dekat Ulen tu, cuma ini saya dah simplify sikit lah. Okay, so the train engine at E has a speed of 20 meter per second and acceleration of 40 meter per second squared in the direction shown. Find the rate of, kalau tak nampak sekejap. Okay. Right. Train engine, he has speed of 20 meter per second and acceleration of 14 meter per second squared. Find the rate of increase the train speed and the radius of curvature P of the path. Okay, so find the rate increase in train speed. Rate ni apa dalam bahasa Melayu? Rate tu kadar. Okay, rate adalah kadar. Rate adalah kadar. Okay, bila kadar ni mesti dia berhubung kait dengan masa. Okay, in relation with time. So rate of increase the train speed. So maknanya nak cari dv over dt lah. Okay, and radius of curvature of the path. Ini straightforward lah, ini rule. Okay. So diberi A 14 meter per second square. Diminta cari what is dv over dt. So you know that A tangent is equals to dv over dt. And then you know A normal is v squared over rho. Kan? So apa A tangent? So A tangent tu mestilah sini lah. Ini adalah A. So sini adalah A normal. Right? So A tangent is you can simplify or using theorem Pythagoras lah. Okay. So A tangent is equals to 14 cos 75. Berapa tu? 3.62. So 3.62 meter second. And then A normal adalah 75 sin 75 sin pula. 14 sin 75 degree. (13.5). Okay, so 13.5 meter per second square. Okay. Okay. So masukkannya lah. So 80 equals to 3.62 meter per second square. Okay. And then AN is equals to V squared over rho is equals to 13.5. Okay. Diberi V is equals to 20. Ini. Okay, masukkan saja 20 squared over rho 13.5. So rho is equal to 29.6 meter. Okay. Boleh? Boleh kan? Okay, kalau ada soalan bertanya. Kalau tak ada, saya teruskan. Okay, kita lihat yang ini. Okay. Okay. Okay, this is special case lah. Special case number, saya rasa number 4 yang tadi. Gunakan equation yang panjang. Okay. When the skier reach point A along the parabolic path in this figure, he has speed of 6 meter per second, which is increasing at 2 meter per second squared. Determine the direction of his velocity and direction and magnitude of his acceleration at this instant. So macam mana nak buat? Macam mana nak buat tu? So dia beri speed of 6 meter yang apa? Skier ni turun lah, dia turun daripada atas and then sampai bawah ni lah. Okay. On my skateboard, ya, turun daripada atas, turun daripada atas ni turun ke bawah. So at the instant pada A ni, okay, at this is A, location A ni. So he has speed of 6 meter per second. So you have V 6 meter per second, which is increasing at 2 meter per second square. So kalau dia beritahu macam ni, itu adalah increasing of speed, that's mean dv over dt lah, is equals to A tangent is equals to 2 meter per second square. Okay, increasing ni maksudnya dia sama macam tadi lah, like before. Okay. Determine the direction of his velocity and the direction and magnitude of his acceleration at this instant. Neglect the size of skier in the calculations. Determine the direction of his velocity. Apa direction dia? Ingat, velocity is always tangent. Okay, velocity always tangent to the path. So kalau tangent, you have mana dah? Sekejap hilang. Okay, velocity is always tangent to the path. So here is your position A kan. So here is tangent lah. Here is your V. Okay. So direction dia ukur lah. Gunakan segitiga. So here is 5, here is 10. Okay, berapa sudut ni? Theta. Okay. Ya ke macam tu? 10 ni sampai sini. Kita nak sampai sini je. Berapa jarak ni? Sepuluh kuasa 2 bagi 25. Berapa jarak? Berapa angle tu? Okay. Dia tangent kan? Okay, dia tangent. Tangent macam ni. Okay. Berapakah jarak ni? Angle ni berapa? So tangent, kalau you remember, tangent slope adalah dy over dx. Okay. So slope at A is equals to dy over dx. Okay. At A lah. Okay. So given y is equals to 1 over 20x squared. Okay. So dy over dx adalah 1 over 10x. Okay. So since x equals to 10 meter, so dy over dx is equals to 1. Okay, 1. So kalau kita lukiskan segitiga, so this is dy and then this is dx. Okay, so what is angle here? So here is, let's say 1, here is 1. So theta adalah 45 degree. Okay. Inverse 1 lah. Okay, thank you. 45 degree. Okay. Okay, so cara lain dia, you boleh buat tan inverse dy dx lah. Okay, tan inverse. Tan inverse dy over dx is equals to tan inverse. Okay. Okay. Magnitude is acceleration. Okay, now what is the magnitude of his acceleration at the instant? Okay, so for this skyer, you have A tangent and then you have A normal. Okay, ingat arah normal adalah towards the center of curve. Okay, bukannya kat sini kalau kat sini AN salah lah. Okay, dia mesti ke dalam lengkungan. Right? Okay, what is AN? So AN 80 dulu lah. So 80 dv over dt kita dah dapat tadi, iaitu 2 meter per second square. AN is v squared over rho. So v is 6 squared over rho. Rho ni yang kena carinya. Okay. Sini lah kat sini. Boleh. So what is rho? Rho is equals to tadi yang apa? Yang equation yang special case. Special case tu. Yang ini. Okay, rho tu yang ini lah. Okay, saya tak sini. Okay. Rho tu yang ini. Okay. Right. So you have rho is equals to 1 plus dy over dx squared kuasa 3/2 d squared y over dx squared.
So
Ya.
yang v squared over rho tu memang tu formula dia.
Betul. Itu formula untuk AN lah. A normal.
Okay, thank you, sir.
Okay. Ni saya padam lah. Boleh tak? Okay. So what is, so kita tahu V is Y is equals to 1 over 20 x squared. Okay. Y is equals to 1 over 10x. D squared Y over x is equals to 1 over 10. Right. So masukkan dalam equations, you have rho is equals to 1 plus dy over x 1 over 10 1 over x square 3 over 2 divided by apa simbol ni, modulus d squared y over dx squared 1 over 10. Okay. Gunakan equation yang ini, this untuk mencari rho. Okay, untuk mencari rho. Okay. Okay, so apa nilai x ni? Okay, semua boleh masuk kan nilai x. So is equals to okay, x ni, okay, which x you must include here? Which x ini? Ini sudah saya silap ni, which x? You kena tengok balik pada at this location A. At this location A, so your x coordinate adalah 10. Okay, x coordinate adalah 10. Sini 10. So you masukkan 10 kat situ. Okay, ya, 3. Okay. So ini dapat 1 plus 1. 3 over 2. 1 over 10. Apa tu? 2 kuasa 3 per 2 darab 10. 28.28. 28. Okay, so this is your radius lah. Okay, radius. Rho kat sini, somewhere here lah. Okay. Your radius aperture. Right? Masukkan rho dalam ni. Okay, so you have AS to C over 20. Okay, 1.27. 1.27 meter can square. Okay. Boleh So what is the magnitude? Magnitude you just square then square root saja. Okay, square dan square root. Tak ada tempat dah nak tulis ni. Tulis kat ni lah. So A is equals to 2 squared plus 1.27 square root. Okay. 0.37. 2.2. Okay, so this is your A, this is A tangent, dan satu lagi A normal. So this is A tangent, this is normal. So sini 1.27, and here is 2. Okay, so your direction or your magnitude kat sini, right? Boleh
So yang direction tu macam mana pula?
Direction A ke direction V?
Dua-dua.
Tadi V dah. Yang V dah Yang V tadi 45.
Oh yang dy over x tu.
Itu ialah velocity lah.
Kalau A?
Kalau A, kalau A you kena buat tangent sama je. Sekejap, saya padam. Okay, so now you have A normal sini. Satu peluang 2 tu. And then you have A tangent sini. Berapa? 2 kan? 2. So your direction sama kat sini lah. Okay, so your ataupun theta bawah. Okay, sini. Theta ini. So theta is equals to tan inverse n. So itulah you punya direction. Okay, so kalau dalam exam you tulis macam tu je lah. You lukis ni, then tulis ke theta ni berapa. So tan inverse an over 80. Kau tak nampak. Okay, dekat sini lah. Okay, sini je. Okay, ini. Kan? So you ada A tangent, okay, and then you have A normal 2.37 kan, 2.3 1.27 1.27. So your direction, label kau yang mana theta, katakan theta yang bawah. Kalau yang ambil theta yang bawah, ia adalah tan inverse 1.2. Okay. Okay, 32.4 degree. Ataupun kalau yang ambil yang theta atas ni, ini theta 2 lah. So theta 2 equals to tan inverse A tangent over A, an. Okay. 2 over 1 27.58 degree. Okay, it depends lah. Ini sebenarnya segitiga je. Okay, jangan confuse, ini segitiga saja. Okay, kalau you lukis macam AN AT kan, so angle ni okay. sama saja. Right? Pakaitan. Okay. Ada soalan? Kalau ada, kat sini saya rasa ada solution. You boleh tengok lah nanti saya bagi slide ni. Alright. Okay, saya nak tunjuk itu. Nak dapatkan gunakan equation yang ini. This equation. How you want to apply these equations to find what is row lah. Okay, what is row. Right? Alamak. Kenapa sih putus je? Ada soalan? Sekejap dia tak boleh nak share. Okay, ada soalan tak? Kalau tak ada, saya teruskan dengan section seterusnya, iaitu cylindrical components. Okay, cylindrical components. Okay, let's say you have one particle moving dalam bentuk curve. Okay, tapi kali ini in polar coordinates. Okay, contoh yang saya boleh tunjuk adalah, okay, contohnya yang ini. Tengok gambar je dulu, jangan tengok soalan. Tengok gambar dulu. Tak apa, saya tak sini ya. Okay, contohnya ini. Okay, so katakan bola ni ataupun guli ni, this marble inside the slot of this. Okay, this is this lah. Then this is marble. And this is slot. This ni dia berpusing. Okay, this turn this way. Okay, contohnya di turn. Okay, so this marble akan berpusing juga, follow, berpusing. At the same time dia akan bergerak ke sini. Kan? Marble dia akan berpusing, dia akan rotate, it will rotate these directions. At the same time dia akan moving towards this direction. Okay, so dia ada dua movement. Okay, one movement is according to theta, okay, rotation ataupun theta, and one movement is in radial. Okay, radial. Okay, pada masa yang sama dia berpusing pada arah theta. At the same time dia moving outside the slot. Okay, in R direction. So you have theta direction and radial direction. So in this case tak sesuai kalau kita nak if you want to analyze using xy or normal tangent. Okay, tak sesuai lah, susah. Okay, so method yang seterusnya adalah cylindrical method, iaitu kita panggil sebagai r theta. Okay, radial dan theta. Okay, r theta method, r theta coordinates. Okay, ada contoh lain tak? Tak ada dah. Okay, so untuk theta dan r ni, they have similar. You have velocity and then you have the accelerations. Velocity and accelerations. So what is velocity in radial? Okay, so velocity in radial kita akan panggil sebagai VR is equals to R dot, and V theta is equals to R theta dot. Okay, contohnya yang ini, bola ni dia bergerak ke sana, okay, dan dia keluar towards outside the slot. So what is the V? What is V in theta direction? What is velocity in radial directions? Okay, and then what is acceleration in theta direction, and what is acceleration in radial directions? Okay, ni dah ada equation ni dah. Kalau you nak know how they derive this equation, you can refer to textbook lah. Okay, sini saya tunjuk je equation ni. So VR is basically is equals to R dot, V theta is equals to R theta dot. So equation ni you no need to remember. Kalau masuk exam pun kita akan bagi lah, we will give this equation. Maksud dot tu apa? R dot is equals to dr over d. Okay, dot tu bermaksud over dt lah. Okay, so R theta dot means R d theta over, right? So itu that is for velocity. For accelerations, equation ni panjang sikit. So you have A in radial and A in theta. Okay, so AR is equals to R double dot minus R theta dot. Okay, dari segi panjangnya adalah D squared R over dt squared minus R dr over dt, d theta over dt. So A theta is R theta double dot to R dot. Okay, the long equation is R squared theta dt squared plus d dt. Okay, so no need to remember. You given during exam lah. Kalau exam face to face lah. Kalau exam online tak bagilah. You carilah sendiri dekat nota. Okay. Okay. Tengok sikit soalan dia. Alright. So the platform is rotating such that at any instant its angular positions is theta is equals to 4t 3/2 radian, where t in second. The ball rolls outward so that its position is r is equals to 0.13 t cubed. Find magnitude of velocity and acceleration of the ball when t is equals to 1.5 second. So bola ni dia berpusing, di sini berpusing. Okay, so katakan this is t is equals to 0. Okay, so when t is equals to 1.5, let's say dekat sini lah. Okay, so bola ni pun dah terkeluar sikit. So the ball is now at here. T is equals to 1.5. Okay, so dia dah move sebanyak theta dan dia juga move R. Okay, boleh? So what is the acceleration and what is the velocity and acceleration? So soalan ni paling senang kalau you boleh disenaraikan dulu all the theta and R. So theta is equals to 4 T 3/2 theta dot is berapa tu? Bezakan terhadap you have 12/2 T kan? Theta double dot is equals to 6 lah. Yang ni you okay, so R
So
0.1 T kuasa T. Soalan ke? So R is okay, then R double dot is 0.6 T. Okay. Boleh senaraikan dulu, list down all the theta, theta dot and theta double dot, R, R dot and R double dot.
so yang theta dot tu power dia berapa?
Tak ada power kan? Power 1 kan?
Bukan 3/2 terhadap 1 kan?
Betul lah. betul. Apa? 1/2 lah. 3/2
Betul, sir.
tolak 2/2. Okey, baik. Terima kasih. Okey, masukkanlah. Find what is V, R, V, theta, and then A, R, apa dia? A, theta, what is? So V is equals to V, R squared plus V, theta square root. Okay. Boleh buat sekejap? Ataupun nak senang, you masukkan dulu nilai dia. Okay. Sebab you dah beritahu T is equals to 1.5. Masukkan dulu nilai dia. Okay. So theta is equals to 4 1.5 besar 3/2 6. Satu kali 5 kuasa 3/2 darab 7.348. 7.4. Okay, ini at T is equals to 1.5. Okay, so at T is equals to 1.5 second. So theta dot darab 6 sama juga 7.348. 7.38 and then theta double dot ni salah dah ni, negatif 1/2 kan, this is minus 1. Okay. Boleh sama-sama kira 2.449. So 2.449, right? And then you have R 1.5 cube darab 1 0.3375 0.3375 R dot is equal to 0.635. Okay, R double dot 6 darab 1.5 0.9 0.9. Okay, masukkan dalam equations. Kalau tak boleh tengok balik VR is equals to R dot R theta dot. So this is equals to R dot, here is R dot. Okay, and then for AR you have R double dot minus R theta dot square. R double dot R theta dot square. Okay, and then A theta R double R theta double dot R theta double dot plus 2R dot theta dot. Okay, masukkan saja nilai ni. Sepatutnya dapat jawapan lah. Okay, rasa ada solution kot. Masukkan saja nilai. Okay, you have R dot R double dot. Okay, theta pun sama. Masukkan saja dalam equation ni. Okay, masukkan saja. So you should get the answer lah. Okay, itu untuk V. Okay, for A pun sama. Just masukkan dalam equations. Okay, masukkan dalam equations. You dapat A. So this is R double dot minus R dot square. Okay, so this one is for AR and then this one for A theta. Okay, disekalikan. So sebenarnya sama je. Okay, sama saja. So this is AR and then this is A theta. Okay, and this is AR squared plus A theta squared and then square root saja. Okay, soalan? Okay, kalau tak ada, saya teruskan. Dependent motions. Okay, dependent motions. In many kinematics problem, the motion of one object will depends on the motion of another object. For example, the blocks in this figure are connected by an inextensible cord. Maksud inextensible ni dia tak boleh regang lah. Okay. Tak regang. Macam getah tu tak boleh lah. Dia tak regang. Okay. Wrap around a pulley. If a block A move downwards along the inclined plane, block B will move up the other incline. Okay, betul tu. Kalau A ni bergerak ke bawah 5 meter, yang B juga akan naik ke atas banyak 5 meter, kan? Dengan syarat tali tu dia rigid lah, okay? The rope is rigid, bukannya macam getah tu tak boleh lah. Getah tu memang tak boleh lah. Turun 5 meter, naik mungkin 3 meter je kot. So kalau tali tu rigid, so you turun 5 meter, yang B pun naik 5 meter. Okay. So that is we call dependent motion lah. Pergerakan yang bergantung kepada partikel yang lain. So the motion of each block can be related mathematically by defining position coordinates SA and SB. Okay, so dalam kes ni SA is equals to SB. Okay, here is SA, jarak lah, position, and here is SB. Okay, ikut logik yang sama, VB and S equals to B. Okay, kalau here 5 meter and then katakan dia move dengan 8 meter per second. Yang ni pun sama, akan bergerak ke atas banyak 8 meter per second square. Right? Katakan blok ni dia turun dengan acceleration meter per second square. Blok B juga akan naik sebanyak 3 meter per second square. So they relate dengan this mathematical equations. Okay, boleh? Tak apalah, kita sama je. Sama je saya terang tadi. Okay, cuba tengok contoh yang susah sikit. Consider a more complicated example. Okay, so you have position coordinates SA and SB are defined from fixed datum line. Sekejap. Okay. Note that SB is only defined to the center of the pulley above block B, not until block B, since the block move with the pulley also H is constant. The red color segment of the cord remain constant in length during motion of block. So untuk selesaikan masalah ini, kita kena define which cord yang tak berubah. Okay, which cord yang tak berubah panjang dia. Okay, contoh yang atas ni So kalaulah yang A ni bergerak ke bawah, B ni gerak ke atas. Okay, so this length SA pada asalnya panjang macam ni. Okay, so bila dia bergerak ke bawah, when it move below, okay, asalnya let's say SA is 3 meter. Okay, and then SB ni let's say 2 meter. When it move ke bawah, so SA ni mungkin dah jadi panjang lah. Maybe dia jadi 4 meter, dah jadi panjang. Dia duduk kat sini lah, A, kan. Ni dia pendek lah. So yang ni mungkin dah jadi 1 meter, dah pendek. Right? Tapi yang merah ni, yang kat sini, the one is touching the pulley is constant. Okay, the one touching with the pulley is constant. Dia tak berubah. Okay, dia tak berubah. Constant, tak berubah. Okay, so untuk case ni we can say SA plus katakan panjang ni CD, LCD. LCD. Okay, and plus SB. Okay, is equal total length of total length of the rope. Ni bentuk L ni bentuk takut salah. L lah, sebut L. Okay. Katakan L CD dengan L total. Okay. So SA plus length CD plus SB is equals to total length of the rope. Okay. So kalau saya differentiate kan in the S over D kan, right, differentiate position, you will get velocity. Okay, so differentiate kan SA, you will get VA. LCD ni constant, right? So you differentiate constant, you will get 0 lah. People differentiate 0. Okay, so you will get B equals C. Okay, boleh constant, you will get 0. ds over dt. Okay, differentiate constant, you will get 0 lah. Okay, so from VA VB ni kita boleh assume A is VB over dt. Boleh Okay, kita tengok contoh yang ini. Ini susah sikit. Okay. Alright. So this length, kita ada block and you have block A and block B. Okay. So this length dia tak berubah. Kita ukur daripada datum. Okay. Untuk selesaikan masalah ni kita kena set satu datum. Okay. For each particle you kena set satu datum. Datum tu boleh jadi at the pulley or on the wall. Okay, or on the wall. Let's say in this example, we set datum here. We set here is your datum. Okay, and then this is datum. Datum ni for this particle and this datum for this particle. Okay, nanti saya tunjuk. So kita assume yang ini tak berubah. Yang ini tak panjang, yang ini also is not constant. This one constant. Yang ini pun sepatutnya constant juga. Okay, tapi kita boleh, we can put. Okay, so total length of the rope. Okay, total length of the rope. Start from datum. We have SB. Okay, this SB Okay, and then distance from A is we call it as H, or you can call it any name. Sebab apa? Ini constant, kita namakan saja dengan H, and then this is SA. Okay. Kemudian kita tambah total length of the row. Okay, start dengan level. Here is SB, so distance, okay, SB. And then here is, let's say we call it as a H. Berubah, and then here is SA. Okay. So how many SB kita ada? Kita ada satu SB. We have 2 SB. So you have 2 SB plus H. Plus H yang ini. This H plus SA. Alright. Is equals to total length of the row. Okay. Total length of the row. And then we differentiate dia. DSGT is equals to, right? So you can dapat 2 is DA. Okay. Kita assume when we set the datum, there are two things. Okay. This is datum. Kita set yang ke bawah ini adalah positif. Plus adalah depends on your datum. Kalau kita set datum sini, positif. Right? Okay. Okay, kalau tak faham tak apa, kita tengok nanti. Okay, ini kalau I put the datum at the below. Okay, saya letak datum kat bawah. This is your new datum. Okay, when you have new datum, so yang atas adalah, yang bawah ni adalah negatif. Ini datum yang sama, so you have positive, right? So kita ukur panjang tali. Okay, we measure the length of the rope. First, this length. What is that length? So you have H minus SB. Kan? So this length is H minus SB. Okay. H minus SB. And then what is this length? Sama. H minus SB juga. H minus SB. Right? And then this length, H. Okay. That length is H. And then what is this length? This length is SA. Okay. SA. So tambah je lah. So you have 2 H minus SB plus H plus SA is equals to total length of the rope. Okay, so you differentiate dengan dia, you akan dapat, so 2B is equals to 2A. Ini kalau saya simplify kan, dapat 2H minus 2SB plus H plus, okay, so differentiate kan, dapatlah. So this one becomes 0, this one becomes 0, SB is equals to SA. Okay, so we get these equations. Okay. So bila A ni bergerak ke is move, so when this A move to the right, yang B akan naik ke atas. Kan? So positive, this one positive. So that's why you get 2 positif lah, right? Soalan sebelum ni, contoh sebelum ni, you get negative. Sebab apa? When A move to the right, positif, B ni dia akan naik ke atas. Okay? Atas simbol dia ada negatif. Ini. So this one is negative. Sebab tu you dapat this equation equals to minus VA. Okay? Right? So 2 times lah. Kalau kat sini 3 meter per second, here must be 6 meter per second. Okay? 2 times. Okay? Depends on your datum. Okay? Depends on your datum. Tengok soalan lain lah. Okay? Tengok soalan senang sikit. Inilah. Ini. Kita tengok yang ni. Nombor ni senang faham sikit kan? Okay, in this pulley system, block A is moving downward with speed of 4 meter per second. Okay, bawah 4 meter per second. While block C is moving upward. So what is, kalau A ke bawah, what is block B? What is B? Tahu kan? So what is VB? So equation ni you guna gunakanlah kaedah dependent motion. So first set the term. So case ini, for this case, the easiest way is find the term near the wall. Okay, so this is your datum. Okay, datum. So we can say that ke bawah adalah positif. Okay, so find what is, kemudian label. Okay, you need to label for each particle. Okay, dalam ni ada 3 particle lah. Kita panggil dia, we call it as a particle A, particle B and particle C. So you have SA, and then kita ada SD. Okay, seleloknya kita pergi kepada puli saja. Okay, kalau nak turun sampai ke bawah ni boleh, tapi this length is tak berubah. Okay, better kita ambil sehingga until the pulley je. Alright, so this is SB, and then here is S. Okay, for each particle. Okay, for each particle. So ada 3 lah. Okay, kemudian set the term 2 is label position lah. SC. Right, and number 3 you need to measure length. Measure. So start dengan sini. So length for the, so for that length we have SA, kan? Kemudian what is length for this? Have SB. And then what is length for this rope? Sama, you have SB. And then what is length for this rope? Have SC. Okay, SC is equal equal to of the row, right? So simplify, you get the S A plus 2SB plus S to T. Differentiate kan over time, you will get VA to B plus V0. Okay, differentiate kan sekali lagi to AB. Okay, so find the speed of block B. So what is VA? VA, so gunakan equation yang inilah, carikan speed of VB. So kita ada VA is ke bawah is positive. Plus 2 VB. Okay, kita dah assume datum macam ni, so ke bawah adalah is equals to 0. So VB equal to 2 minus 4 divided by 2 minus 1 minus per second, or meter per second and upward. Okay. Boleh gunalah any sign lah yang boleh pakai. Alright. Boleh? Boleh? Ke tak boleh? Kalau boleh, kita tengok contoh yang ada 2 tali. You have 2 rope. Ini. Okay. Boleh buat? Faham tak faham ni? Faham kan? Harap faham lah. In the figure on the left, the chord at A, if you have 2 chords, you must develop 2 equations. Okay, example. The chord at A is pulled down with speed of 2 meter per second. Find the speed of block B. Right. Ingat first step apa? Set datum. So kat sini datum kita. Okay. So kalau datum ke bawah positif, sebenarnya sini adalah positif. Bawah adalah positif. Yang kedua, number 2, you need to set position of each particle. Dalam kes ini particle adalah puli lah. Particle. Right? Ataupun tangan. Okay, tangan juga. Okay. So you have banyak tu. You have SA, kemudian kita ada SC ini, SC, and then kita ada SB. Okay, you nak bawah ni pun tak gerak. Ini adalah constant. Okay, you touch macam mana pun, whatever you pull down the B, this distance is constant. So better you just take SB up to the pulley saja. Right? Okay. So next step is calculate the distance. Calculate rope. Okay. For each rope, okay. So the first rope you have ini, ini. Apa tu? Dia punya equation dia. So you have S rope. Okay. So you have plus SC, SA plus SC. SA plus SC plus SC is equals to length of, okay. Kemudian rope yang satu lagi, lain lah. Okay, so this rope block. Tu. Apa panjang tu? We have SB plus SB minus SC. Kan? So you have rope 2. Sini. We have plus B of rope. Okay, so this is SB. Okay, so yang ini my SC. Right? So macam mana buat tu? So yang ini adalah SA. So this one is SA plus and then this is 2 SC minus SC length 2. Okay. So solvekan equation serentak ni. So this is, let's say, equation number 1, this is equation number 2. Okay. Eliminkan SC. Okay, so ini you dapat SB 2, simplify je lah. Right. So eliminatekan SC ini. SC ini pun sama. SC ni plus lah maknanya. Ni plus. Ini matematik je. So 1 plus 2. Okay, you dapat SA plus 4SB is equals to 2LT2 plus L. Right, so this is equation number 3. Okay, so differentiate kan, dS over dt, you akan dapat A plus 4VB is plus 4VB. VB is equal. Okay. Dia masukkan dalam equation, what is the speed of block B? Okay, tanya kan, what is speed of block B? Masukkannya lah. So VA, A tu ke bawah. Okay. Going down is positive. Ini kan, going down is positive. Have positive 2. Di situ V is minus 0 meter or 0.5 meter per second. So ini going up lah, 0.5. Okay. Boleh? Ada tak ni? Ke tak ada dah? Ada kan? Okey, baik. Kalau tak ada soalan, kita tengok section seterusnya. Ini saya memang saya tekad nak habiskan chapter ni. Nanti kita buat tutorial. Okey. Motions. Relative motion analysis. Apa dia keluar macam tu? Okay. There are cases where the path of the motion of a particle is complicated, visible to analyze the motion in parts by using relative motion. Contohnya, for example, we have dua car yang bergerak lah. Contohnya kita bawa kereta kan dekat highway. Contohnya saya pergi daripada KL pergi Melaka kan. Dan satu kereta ni, katakan kereta ni kereta BMW kan. BMW. Dia bergerak dengan 200 km per hour. Okay. Kemudian satu lagi kereta bergerak dengan laju ini kereta Asia 80 per hour. Okay, so apakah relative motion between these two car? Kereta BMW cakap aku dah agak laju dah 200 km sejam ni. Okay, tapi Asia cakap mana ada, slow je tengok kan. Rupanya Asia tengok BMW tu dia bergerak secara relative motion. Okay, Asia dia nampak BMW move only at 200 minus 80 saja. So dia nampak dalam 120 per hour saja. Okay, so itu adalah relative motion lah between two to particle. Alright. So Azia nampak BMW tu seolah-olah dia bergerak slow je lah. Okay. So satu lagi kereta Mercedes kan. Kereta Mercedes. Dia pun bergerak sama juga. 200 km. Okay. So relative motion between BMW and Mercedes adalah seolah-olah dia bergerak sama-sama. Okay. Seolah-olah dia adalah zero velocity. Okay. So itu adalah konsep relative motion lah. So for example kita ada car A, okay, diukur is measured from origin. So let's say this is origin. Distance RA and car B, the distance are RB. So the position of B with respect to A can be as these equations. Okay. RB is equals to RA plus RB slash A. Okay, it mesti sama. Okay, this must be same. B, A. So similarly, the position of A can be written as AB. Sini AB. Okay. So the position of B with respect to A, you have these equations. BA. Position of A with respect to B, you have this equation. Okay. So that is for positions. Alright. So for velocity, mana dah pergi ni? In plus. So velocity of B with respect to A can be written as VB plus VA. VB is equal to VA plus VB stroke A. Okay. So if you have velocity of A with respect to VA, right? So the acceleration of B with respect to A, you have this equation. Okay. So sebenarnya jawapan dia adalah yang ini. Okay. Dia tanya what is acceleration of B with respect to A? Yang ini lah. Okay. Bukan yang ini. Yang ini. Yang ada slash, right? Slash. So note that this relation is vector quantities. So we need to solve in xt or normal tangent coordinate. So you're going to pecahkan x and also y coordinates. Okay. Example. We have a train travel at constant speed 60 km per hour and cross over a road as shown in the figure. If car A is traveling at 45 km per hour, determine the magnitude and direction of velocity of the train related to velocity. Okay, velocity. So what is velocity of train with respect to mobile? Macam tu cara tulis. What is velocity of train with respect to automobile? So VT yes, VA. Ingat dia kena sama. You start dengan T kemudian A, ini besar. T kemudian A. Okay, jangan tertukar. Right? So the question is asking what is the velocity of train relative to automobile. Okay, as I said, you kena solve ni ikut follow the vector quantity. Okay, I dan J. Kan? Kalau X, Y, vector dia adalah I dan J lah. Okay. So V slash A equals to, what is velocity for train? Mana train? Ini 60 km per hour to the right. Okay, to the right. So you have 60 I, okay, I minus VA. VA itu adalah automobile. Sini ada angle kalau tak nampak, they have angle 45 degree. Okay, 45 degree. So the angle is 5, so you have 45 cos plus 45 sin J. Okay. Kalau ini macam dipecahkan lah. Ini ada nampak ni. Sini kan 45, okay, 45. So pecahkan ada 45, 45. Yang atas ni, yang 60 ni satu arah, ini aja arah S direction. Okay. So solve lah macam biasa. Solve kan I plus I, J and J, jangan mix up. So you have T minus cos 4 I sin, right? So 60 tolong 5 cos 45. 28.18 I minus 45 sin 45. Tiga 82. Okay. Determine the magnitude and directions. Okay, so magnitude is 8.1. So 42.5 millisecond. Direction and first J over I minus 40 minus over 21. Right? Negative 48 degree minus 48 degree. Okay. Kalau ditanya what is automobile relative to train, VAT is to VA. Okay, contoh lah, kita tengok panjang sikit lah, yang sebab ni sikit je. Ni benda yang sama lah. Okay, the same thing. Soalan tak? Ada? Ada soalan tak? Okay, ini you boleh tengok lah. Macam nak solve. Ini ada solution lah. Okay, you boleh tengok. Okay, ada soalan? Last ada soalan? Dah habis dah chapter 1. Nanti kita buat latihan lah. Tak ada soalan. Ni dah habis. Dah habis. Okay. So dah pukul 4. So kalau soalan, kita we stop here and we see pada Khamis boleh?
Boleh sir.
Okay. Boleh, kita jumpa hari Khamis. Okay, terima kasih semua. Terima kasih semua. Nanti saya upload dekat inilah.
Doktor, hari Khamis
Apa dia?
hari Khamis tu online ke face to face?
Buat masa ni online lah. Buat online dulu. Boleh?
Boleh.
Okay. Hari Khamis.
Thank you, Doktor.
Thank you, doktor.
Doktor.